one more composition problem, and it's one with a square on f of x. And I just want to show you how that ends up playing out when you work those. It's also just a good review for any of you for what we did on Thursday. So the first one is f of x. How do I do that? First thing I need to do is rewrite as f of g of x. Okay, you got it? I will grade it. If you don't come back and check 7th hour post grade, if it goes in at 50 out of 50, yeah. Any questions so far? Okay, and then I'm going to put g of x inside that parentheses. F of 4 minus 3x. Nothing so far should be any different than what we did on Thursday. This next part is why I wanted to do this problem, because a lot of people mess this up. It's one of the most common mistakes in math classes. And that's dealing incorrectly with that square. What does a square mean? Multiplying it by itself, which is not squaring everything in the parentheses. Star that in your notes. A square means multiplying whatever is squared by itself. You cannot just square everything in the parentheses. It doesn't work that way. Again, one of the most common mistakes in math classes from Algebra 1 up. So, what I need to do to finish this problem, I need to write that as 4 minus 3x times 4 minus 3x. And then distribute that out or FOIL that out. Does everyone see what I'm talking about with a very common mistake? How many of you might have done that if I had said that? Okay, so start in your notes. We know that's a big place where we might mess up. Make sure you don't distribute a square over a plus or minus. The place that misconception comes from is you can do that if everything is multiplied. You can just square everything. But if there's a plus or minus, you can't distribute a square over a plus or minus. Minus 12x plus 9x squared plus 2. So I get 9x squared minus 24x plus 18. And that is f of g of x. Again, the big thing there is just be careful if you have a function squared, you have to multiply by itself. It's really the only new thing for the day. So you might want to go back and check your homework and make sure you didn't do that already. Okay, let's do f of g of -1. I know that I have f of g of x sitting down here, so I could steal that word, but I'm going to work it as if I hadn't done that just for homework purposes. How do you rewrite f of g of -1? The time that you put -1 in for both is if it's multiplication, addition, subtraction, any of those others besides composition. If it's composition, you start with it on the inside function. So I'm going to find g of -1. What is g of -1? 7. Everyone agree? So I'm going to do f of 7. And f of 7, 49 plus 2. The square does not make them any harder. It's just the only time a square makes it a little tougher is if you are where I got that? F of 2. And then I'm going to find G of 6, which is 4 minus 3 times 6. 4 minus 18. Just bringing it back from what we did on Thursday. Last one, G of F of X. And I want to show you this one to let you know that every time there's a square, it's not necessarily a harder one. Depends on which one's inside the other one. This one ends up being G of F of X. And F of X is x squared plus 2. And G is 4 minus 3x. So I'm going to do 4 minus 3 blank. Where the blank is, I'm going to put x squared plus 2. So you can see that on this one, the square didn't create quite the difficulty that it did on the first question. Because the function didn't end up being squared. So this one I just distribute and rearrange. Which highlights again that f of g of x and g of f of x are going to be different answers. Any questions about that?
Teachers, can I have your attention please? Apparently task is down and also eSchool. As soon as we get some information concerning it, I will let you know.
Just one more problem, and again, mainly this actually isn't even on your homework. I mainly just wanted to show you this to show you kind of how a real world problem would incorporate proposition of functions. So as Dillard's is having a huge sale, they are taking 50% off everything in the store. They are taking an additional 20% off their sub items. Write a function f of x to represent the price of an item after 50% off. Now, how do you do that? And this is good ACT work anyway because they do a lot of percentage questions. How would you write a function that would take 50% off? Okay, good. 50% of x. It takes 50% off. Takes 50% of. That works. So that is a function to take 50% off. That's the price of an item after 50%. It's a little tougher when it's not 50%. Write a function g of x to represent the price of an item after 20% is taken off. And there are two ways you can write it. Not yet, just 20%. Just 20% off. Okay, so let's try 0.2x. Okay, so let's actually put money with it. So we got a $100 item, and we do 0.2 times 100. What would we get? Is that really the price of the item? That's how much you take off. So how would I write the function? 2 ways. Work. Multiplying by 0.2 gives you the amount you're taking off the price, right? Okay, good. One option is doing x minus 0.2x. Yeah, isn't that just 80%? 1 whole x minus 0.2. Makes sense. That you're paying 80% of the item if you get 20% off. So next time you're in a store and you need that percentage really quick, if you're taking 20% off, multiply by 0.8. If you're taking 30% off, multiply by 0.7. ACT skill, make it a lot faster. If you're taking off, you can do the percentage or the percent that's left. Okay, so if you didn't know that, that's nice to know. Save you a little time. Okay, anyway, those are F and G. Any questions? questions on that? Use a composition of functions to find the price of an item after both price adjustments that originally cost $50. So I'm going to rewrite that. Which one is the one I'm doing first? The 50%, right? So wouldn't that be the inside function? Wouldn't that be the inside function? Everyone agree? So that would be g of f of x. And I actually could say to myself, I want g of f of $50. So f of 50, half of 50 would be 25. Everyone agree? And then 80% of 25, 20. So a $50 item would cost $20. Any questions about that? Does the order in which you make the adjustments matter? Well, sometimes we know it does. We know composition of function does not work in any order. Well, but we need to try this. Maybe this composition of functions does. So I'm just going to try it. So I'm going to do 80% of 50. Try it. 80% of 50 and then take off the 50. So 0.8 times 50 and then 0.5. It turns out that it works the same on this particular problem because it's multiplication, and you can multiply in any order. Does that make sense? So you multiply by 0.5, then you multiply by 0.8. There's no subtraction involved or things that would throw off our order. So in this particular problem, it doesn't make a difference. But most of the time, rearranging a composition does make a difference. Any questions about that one? I just wanted you to see kind of an application of that, and then we also got to talk about some percentages off and things like that. Your composition of function worksheet is due tomorrow. I hope you're getting kind of close to finish with it. If not, use the rest of the time in class to finish it. If you're finished today, use the rest of the time in class to work on your review or that mastery exam.